So we are going to be finding area of polygons just like we did yesterday. Same thing, like we did with the hexagon, right? We're going to be finding area of polygons, and we have a formula to find area of polygons. You guys remember the formula, find the area of the polygons? What's that? Not base times height. Area of polygon, like we literally what we did. There's no way. You guys all got good grades on the quiz. Everyone just copied David's work or something. What happened? How do we know how to do this? How do you find the area of a polygon? Thank you. We have our formula. Okay, let's do this. Let's go back to go to the back of the book, back of your comp book, and on the reasons page. Maybe not even on the reasons page. Like, I don't know, at a page close to that or somewhere around there, we can start writing out some formulas. So either have a formula section or maybe somewhere you can easily reference. Let's list out all of our formulas, because we're going to have a lot of formulas. So we need to know the area of a rectangle. Area of a rectangle, how do you find it? There you go. Let's just shout it out and pretend that we're enjoying ourselves. Area of a parallelogram. Base times height. All right, we got the shouting out. We don't have the pretending to enjoy ourselves. But it's okay, we'll get there. A triangle. 1/2 the base times the height. Still no inflection in the voice. What else do we have? A trapezoid. One half the height times the sum of the two bases. I think you were thinking the right thing, though you said it kind of weird. We had a rhombus or a kite. So we're going to draw it like this, rhombus or kite. Rhombus or a kite, we did that yesterday. Times, you're close, 1/2 the diagonal times the diagonal. The way they write that is diagonal 1 and diagonal 2, giving them names. Then we had any polygon. So this works for any polygon, regular polygon. Does this work for trapezoids? It's going to make an awkward recording. It's just sitting there in silence. Does this work for trapezoids? Any regular polygon? You're saying yes, because a trapezoid is a regular polygon. Austin, what makes something a regular polygon? You don't know? Oh, what's important to know? Because this only works for regular polygons. So if it's not a regular polygon, I can't use this. You know what makes something a regular polygon? Mr. B taught this to you in 6th grade. Did you have Mr. B in 6th grade? Oh, you're making him sad right now. Regular polygon. What's a regular polygon? Seriously, your like 5th grade teacher taught you this. What's a regular shape? Don't make us pull the Bella card out for this. This is way too easy. What's a regular shape? Ethan, do you know a regular shape? Oh my goodness. I didn't teach this to you that big of a deal because I just thought everyone knew. Alexis, do you know? Oh my, seriously? Okay. Well, we'll put that, I don't know where to put that in our notes. Like literally, this is something that everyone should know. A regular polygon has all the same sides and all the same angles. That's what a regular polygon is. That's something you guys all should have known coming into this. Thanks, COVID. We'll blame COVID. I'm sure you guys learned that on some lesson that you were like falling asleep at. You turned your camera off or playing video games or something else. A regular polygon has all the same sides and all the same angles. Okay, let's try this again. Is this formula that we're about to write out that only works for regular polygons? Does it work for a trapezoid? Why not, Ben? There you go. See, it doesn't work for trapezoids. But a kite, does it work for a kite? No, it doesn't work for a kite. What about a square? Would it work for a square? Yes, it would. Or a regular octagon, and then I have to tell you a regular. Now you know when you can use this. Okay. That wasn't really the point, but the point was what the formula is. This is what we ended yesterday. What was the one that we ended yesterday with? Someone shout it out with great joy. What was the formula? That's with great joy. Man, you must be really dull at parties. Like that's great joy. 1/2 the apothem times the perimeter. All right. So those are all, we'll add more formulas to this. You guys need to know this stuff and be at least ready to access it if you don't have it memorized. So you need to know when you use this. You use it for a regular shape. You're correct that yesterday we did this with regular hexagons. We did hexagons only yesterday because hexagons are a little bit more predictable. Now we're going to do this with any regular shape, any of them. It could be a dodecagon, a heptagon, a 37gon. You're going to be able to use this formula for any regular polygon. That's what we're going to work on now. Now, the reason why this is a review, what we're going to write right now, a review of hexagons that we did yesterday. The reason why we only did hexagons yesterday is because they're pretty predictable, where it has that 30, 60, 90 degree triangle that comes up. So with a hexagon, we didn't actually have to use the full trig ratios, the sine, the cosine, and the tangent, because we knew a 30, 60, 90 degree triangle comes up in a hexagon, right? So this is what we did. It gave us a hexagon. We would draw the apothem and the radius, and we would draw that right triangle. And then we know that we would apply that right triangle to everything else. And in this right triangle, we knew that there was a relationship. There's the small side. The big side is the small side times the square root of 3, right? And then the hypotenuse is double the small side. That's only for hexagons. But what if we have, and this is what we're going to do today, something that's not as predictable? And I'll take you through the steps for this. Here's one thing. When you guys start working on this, and if you ask for help, I'm going to ask you, what's the first step? And if your answer is, I'm going to leave. You'll have to find these steps. So I get it if you say, well, I don't understand which trig ratio I should use. Okay, I'll help you out with that. But these are the steps that it's going to take. So make sure you have these that you can access as well. Step 1. We are going to write out our formula and figure out what's missing. So step 1 is write 1/2 the apothem times the perimeter with blanks here, and then find what's missing. So when you ask for help, I'm going to ask you, is the apothem missing? Is the perimeter missing? What's missing? Let me give you an example, and we'll do the problems with this example. They're going to say, and here's our example that we'll do along with it. There's going to be a couple examples of this. We're going to find the area. So loud. Of a regular. How many sides do we want this shape to be? 5, sure, pentagon. With side lengths of 15 inches. No, I don't want decimals, 16 inches for now. Okay, so step 1, we're gonna write area equals 1/2 blank times blank. We should right now be able to figure out one of those two blanks, and one of them we can't figure out. What's the blank that we can already figure out? We can already figure this out. What's that? How can you figure out what the perimeter is? That's right. It gives us the side lengths and how many sides. So each side is 16, and we have 5 of them. 5 times 16, 80. Someone check if that's right. That's right. Thank you. Felt good. It was like an amen that he just gave me. I felt like a preacher there for a second. So we got 80. What do we not know? Which one can't we figure out? We don't know the apothem. So step 2. We are going to draw and label the little right triangle. Draw and label the right triangle. Let me talk about the right triangle. Don't draw this whole thing. We're going to skip this every time, but I'm showing you the right triangle we're talking about. Pentagon has 5 sides. Pentagon has 5 sides. 1, 2, 3, 4, 5. This is the right triangle. If we take this, there's 5 of those, then we split that in half. This here is the right triangle that we're going to talk about. So we're going to skip the step of drawing this every time, because what if I said it's a 57-sided figure? Right? You're going to sit there and go, 1, 2, 3, 4, 5, right? We don't need to do that. All we need to do is draw the right triangle and label what we know in the right triangle. So now off to the side underneath here, we're going to draw the right triangle. And we know one of the 3 parts of this right triangle, one of the 3 legs of this right triangle right now. We know the little leg. The little leg is 8. Let's make sure you know why the little leg is always half of that, right? So again, you don't need this picture. This is just an understanding. This side is 16. So that makes this half 8. Good with that? 8. Now, we've got to figure out what the apothem is. We're trying to figure out the apothem because that's what this is. That's the whole purpose of this. But we don't have this side, so we can't use Pythagorean theorem. And we don't have any of the angles. So here's step 3. We are going to find the angle. Find the angle. And I'm going to explain to you how we find the angle. I'll write a formula that I'll explain where it comes from. The way you do that is 360 divided by twice the number of sides. Write that out and I'll show you where that formula comes from. 360 divided by twice the number of sides. How many degrees are in a circle if I went all the way around this thing? Do you guys remember why 360? Yeah, ancient Babylonians counted by 60. It's kind of arbitrary, 360, right? So, okay, 360 goes all the way around. So if I took that 360 and I split it into 5 equal triangles, that would get me this whole entire thing. So, Ben, you seem reliable. 360 divided by 5. So 72 degrees would be this angle here, and this angle there, and that angle, that whole angle. But this triangle is half of that. What's half of 72? 36 degrees. Now, instead of doing that in 2 parts, we did twice the number of sides, right? So if the number of sides is 5, we do 360 divided by 10. Because see, he did divided by 5, then divided by 2. So you could do that if you would like to. You could do divided by the number of sides and then divided by 2 if you would like. That's the same thing as saying 360 divided by twice the number of sides. Aditi, you're giving confused eyebrows. No, I get it. You get it? Okay. I just want to make sure we're good. That's good. I'd rather have you ask and be confused than to just move on. Okay. Now, forget everything that we've done this week. Pretend this week never happened. Think about what we did last week. We have a right triangle with a missing side right here. How are we going to find the side? I get that you're paying attention, Braden. That's good. Let's ask other people. Yeah? We're going to use a trig ratio. That's right. And now it's going to depend on the trig ratio. He says it's tangent. I haven't thought about enough to figure it out. Let's see. Opposite and hypotenuse, opposite and adjacent, excuse me, that's right. So now we're going to do the tangent of 36 equals the opposite over the hypotenuse. Remember doing this fun stuff? We're going to use this now to find the apothem. I'm going to go through this part kind of fast because you guys all got good grades on this test, proving that you know how to do this. Right? So now we would multiply by x. Tangent of 36x equals 8 divided by the tangent of 36 divided by the tangent of 36. X is, can I get multiple people to do 8 divided by the tangent of 36 in their calculator? And we're going to round to the nearest 10th. 11? You guys agree? 11. Good. All of that. Why did we do all of that work? It's not because Mr. Page is telling you to do all of that work. Why did we just do all of that? Why did I draw this stupid triangle? Why did we find the tangent? Why did we do all this? Maybe we'll pull the Bella card out for this. Why? We're finding this blank. All of that was to find the apothem. So now we know the apothem is 11. Now we can use our formula. Now you do 1/2 of 11 times 80. Let's see, half of 80 is 40. 40 times 11 is 440, I think. 440 units squared. Oh, I forgot to keep doing the steps. Step 4. Use trig ratios to find missing pieces. And then step 5, solve it out. I'm going to walk you through a second example of this. And I'm going to show you that it's not the same thing every single time. It's not. It's not the exact same thing every single time. We're going to do a couple different examples. You guys ready for a second example? Do I need to go back, copy anything? No? Okay, example 2. Instead of listing out that whole question, I'm just going to give you the shapes. We're going to have a regular octagon. And the radius, ooh, we talked about what the radius was yesterday. Good thing I'm going to help you with this one. It's going to have a radius of 7 inches. That's all the info we get. Josh, what are we going to do to start? Step 1. Area equals 1/2 blank times blank. So you guys know the radius. I'll draw the radius out. You guys don't need to draw this. I'm not going to, well, I guess I could draw an octagon. 1, 2, 3, 7, 8. The radius is this line here. 7. You don't need to draw that. I'm just being clear what it is. With that, can we figure out what the apothem is? Do we know the apothem? No, we don't know it right now. Can we figure out the perimeter? There's a lot of blanks there. That should either be a yes or no question. Can I do 7 times 8 to get the perimeter? David, you're saying no. Why not? Okay. How come I could do, what was it here? What was the side length? How come in this one I could do 16 times 5 and get the perimeter? Why did I do that? Everyone's just going to take whatever number they give us and multiply it and get the perimeter. Why could I do 16 times 5 there? We have the length of the side. Okay. Is it giving us the length of the side? No. So we don't know that. We can't figure out the perimeter either. So we don't have anything yet. So even though we tried to fill in what's missing, we've got 2 things missing. That's okay. On to step 2, draw the right triangle. So we're going to draw our little right triangle. It doesn't matter what it looks like. And right now, we have one of these 3 sides that we have. It told us one of the 3 sides. What's the side that we have? It's not this one. Which one is it? Yes, no, it's not even the big lake. The big lake is the apothem. The 7, that's right. The radius is also the hypotenuse. So we labeled the 7. Okay. Draw and label the right triangle. We got that. What's next? We got to find this angle. Let's figure out what this angle is. 360 divided by twice the number of sides. Multiple people do that. 22.5. Everyone agree? 22.5? 22.5. Okay. Now we can use this info to figure out the apothem and eventually figure out the perimeter. Alexis, which one do you want to figure out first? It doesn't matter. Do you want to figure out the apothem or do you want to figure out the perimeter? The perimeter. Okay. So to figure out the perimeter, we need this one right here, don't we? And that's half the side. Let's come up with a trig ratio to get that. You're on, Alexis. Give us trig ratio. Uh-oh. Page flipping. Stutter. Very good. the sine of 22.5 equals, so OH. Yeah, you switched them. So we're going to multiply by 7. 7 times the sine of 22.5. Multiple people get that rounded to the nearest tenth. What do we get? 2.7. Everyone agree? So this is 2.7. If half a side is 2.7, what's the perimeter of the octagon? Go away. Wow, we got numbers everywhere. Please say you just said that for comedy. That's okay. We literally, how are we going to find the perimeter of this thing? Yes, 2.7 times 16 is going to get it. Because by 8 is the number of sides, but 2.7 is half of a side. 2.7 times 16, what do we get? So, I forgot to write this. 2.7 equals x. There we go. 43.2. We got the perimeter. All right. No, triangle sums the angles. Use trig ratios to find the missing pieces. We got one missing piece. We've got another missing piece. Emily, what else is missing? The apothem. You want to find the apothem? You guess? All right, let's do it. Let's find the apothem. First off, do not use the 2.7 in Pythagorean theorem because we rounded 2.7. So once you use a rounded numbers, right, the rounded number, it's not going to be accurate enough. You got that? Unless that came up with an exact answer, like it was exactly 2.7, which it wasn't. So don't use the rounded answer. So let's go back to our right triangle and find this missing side here using a trig ratio. Remember, pretend the 2.7 is no longer there. Do you think you can get us a trig ratio for that? Emily's trying to do that. But really, everyone should be. She's just the one that's going to vocalize what she comes up with. She's got the pressure. What are you going to go? Sine, cosine, or tangent? Cosine, that's right, because it's the adjacent overlap. Very good. So we've got the cosine of 22.5 equals very good, 7 over x. I think she was just building drama there, like a dramatic pause. Just so, that was exciting. All right, now we solve this thing out. Multiply both sides by x, multiply by x. Cosine of 22.5 x equals 7 divided by the cosine of 22.5. I'm going through this fast because you learned this last week. You should already know it. And then x equals 7 times the cosine of 22.5. Multiple people solve that out. 6.5, do you agree? Wait, let's agree on 6.5 first, then I'll get your question, okay? You're right. Hey, that's why you take notes in pencil. Sorry, you were correct, Aditi. I cut off your question and I shouldn't have. Cosine of 22.5 equals x over 7 times 7 times 7. So now we need 7 times the cosine of 22.5. 104.4. What do we got? 6.5. Now we've got that and plug in the area. This is all rounded. 140.4. Is that what you said? There you go. You guys agree? Yeah. Now, here's the thing about this, guys. I could come up with like 5 different examples of different things that are missing. But like it would take forever. You follow these steps and know the goal is sometimes you'll know the apothem and you got to figure out the perimeter. Sometimes you'll know the perimeter and figure out the apothem. Sometimes you won't know either of them. Sometimes they could sneak in one and you already know both of them and you don't need any of these dumb trig ratios, right? You're going to have to do some of the thinking there. I would strongly encourage you when you take the test tomorrow, if you don't have this memorized after doing it so much, to have these steps referenced. If you're going to ask me for help, I'm going to do it in the context of these steps. So if you don't know these steps or you can't reference these steps, I can't help you. Let's try these out.